In the previous video, we saw the median and the quartiles. They're often used so that we can describe the location of the average. That would have been our median. That would be where our average is, the middle of our data. And then we had Q1 and Q3. The quartiles are often used to describe spread, the interquartile range. That's fine, but it does exclude some of our data. It doesn't include those extremely low or extremely high values. That can be a good thing for some measures, but other times we want to include all of the data. So we want alternative measures of average and spread that will include all of our data. For that, we tend to use the mean. So the mean is just the simple average that you're used to calculating. So you add up all of the data, which is, let me just check that. One, 4, 7, and then we divide that by the number of data we have, 12. That gives us a mean of 12.25. That's the simple average that you're used to calculating. We then have two measures of spread that we'll use. The first one is what we call variance. What that does is, it works out the difference, the average distance between the mean and your data. Now we can't simply just add up those differences because on average we'll have as much below our mean as we do above the mean by definition. So what we do instead is we, remember from previous videos, this means add up the sum. We add up the squares of each piece of data minus the mean. By squaring it, whether that comes out as positive or negative, we turn it positive and then we divide by the number of pieces of data we have. So what we're actually looking at here is the square, the average of the square of the differences, squaring it to avoid that problem of positives and negatives cancelling out. An alternative form for that formula, which you can derive in class if you want to test yourself, is the sum of x squared over n divided by the mean squared, subtract the mean squared, sorry. Okay, so the sum of the x values squared, so 4, 16, 25, 25, 36, and so on. Add all of those up, divide by n, and then subtract the mean squared. Okay, if we do that in this case, we get a variance of 96.85. Now that in itself is not a very useful measure because it's saying that the average distance squared from the mean is 96.85. What's much more useful is the standard deviation, which we represent with a lowercase sigma. That's uppercase sigma, this is lowercase. That is just the square root of variance. So if we square root that number, we get 9.84. That tells us that on average our data is 9.84 away from this mean. A good way of testing whether it's about right is you take your mean, add, let's call it 10, and subtract 10. If we do that, does it include roughly 2/3 of our data? In this case, I think it does. So like we say, plus minus, if it includes about 2/3-ish, you know you've not made a calculation error. We're happy with this.